Welcome back. So on Tuesday, we finished the lesson talking about simplifying expressions, and we ended up at the problem that ended up like this. We combined our expressions, we got 6x plus 37 equals 180. And then I said the next thing we can do is solve for the variable. So before we do that, I'm going to go into what solving actually means. So when we're solving equations, what we are doing is we're looking for a value of x that makes the equation true. In this case, we have 6 times x, which is some variable that we don't know the answer to. The lights just turned off. So when we have this equation, 6x plus 37 equals 180, we have some number x that is being multiplied by 6 and then adding 37 that's going to give us 180. By solving this equation, we're looking for the number, the value of x that would make this equation true. In order to find that value, our goal is to isolate the variable. We want to get the variable by itself so that our final answer looks like x equals something. Once we get it like this, then we know that that value is what makes this equation true. But in order to get here, what we have to do is undo what is being done to x. We need to preserve equality. What that means is if we do something to this equation to get x by itself, it has to be something that keeps the equation true. So one thing that they usually call the golden rule of algebra is what we are talking about when we're talking about preserving equality. What you do to one side of the equation, you must do to the other. You can think of this like a balance scale. If I were to add some weight to one side, if I added something that weighed 10 pounds to one side, the scale is going to end up tipping to one side. However, if I add that same amount of weight to the other side, it's going to become balanced again. So the idea of solving an equation is that we want to keep that balance. We want to preserve the equality. So if we do something to one side of the equation, in order for it to be true, we have to do the same thing to the other side of the equation. So we know that what we do to one side, we have to do to the other, but how do we know what we need to do and in what order we need to do it? That's where this thing that's called the shoes and socks principle comes into play. The shoes and socks principle says that you have to undo what is being done to your variable in the opposite order that it's being done. It's called the shoes and socks principle because if we look at this chart here, when we're putting on our shoes and socks, this is the order that things are done. First you put on your socks, and then you put on your shoes. If you want to undo that, you have to do it in the opposite order. First you have to take off your shoes, and then you have to take off your socks. You can't take off your socks without taking your shoes off first. Now luckily in math, we actually have something that tells us exactly the order that things are done. That's called the order of operations. You may have heard of PEMDAS. You may have heard of the acronym, please excuse my dear Aunt Sally. What that stands for is parentheses, exponents, multiplication and division. Now these two go at the same time from left to right. Because division can be considered multiplication by the reciprocal. For example, we said before, dividing by 2 is the same thing as multiplying by 1/2. Same thing can be done with addition and subtraction. Subtraction can be seen as adding a negative. So these two go together as well. So this is the order of operations. So when we're talking about undoing something, we have to go in the opposite order than the order that it's being done. When we're solving an equation, we do the order of operations in the opposite order. So we undo addition and subtraction first, then we undo multiplication or division, then we undo exponents, and then we undo parentheses. So going back to this overall question, we want to know what value of x makes this equation true. Now you probably looked at this and said, I already know what to do, but it's good to understand why you're doing it. So when we look at this, we need to know what is being done to x and what do we need to do to undo that. Well, in this expression, remember, expressions go in the order of operations. So we have multiplying by 6 and adding 37. based on the order of operations, multiplication comes first. So the first thing that's being done is we are multiplying by 6. So that dot means multiplying. Then we are, based on our order of operations, after multiplying comes addition and subtraction. So we are adding 37. That's the second thing. The shoes and socks principles says we have to undo them in the opposite order. So we're going to undo this plus 37 by doing the opposite of adding, which is subtracting. So we're going to subtract 37. Then we're going to undo this multiplication by 6 by dividing by 6. So in this equation, that's exactly what I'm going to do. And remember, we need to preserve equality. So if I do it to one side, I need to do it to both sides. So if I'm going to undo the adding 37, I'm going to subtract 37. And if I do it to one side of the equation, I have to do it to the other side as well. Those 37s will cancel out, and we're just left with 6x equals 180 minus 37, which is 143. Now we need to undo the multiplication by 6, so we're going to divide by 6. What I do to one side of the equation, I have to do to the other side. Those will cancel out, and I will get x equals, so I end up getting 23.83, and that 3 repeats forever. Let's look at another problem with context with geometry. So in this problem, we're given that triangle ABC is similar to triangle DEF. I have these two triangles, and we know that they're similar. One thing we know about similar figures is that their corresponding angles are congruent. When two things are congruent, that means they are equal. In this case, I have angle A, which corresponds with angle D. So angle A is this angle, which is represented by the expression 5x minus 5. Then I have angle D, which is represented by the expression 3x plus 8. Since these are similar figures, I know that these two angles are going to be congruent. So if I want to solve for x, I can set up an equation setting these equal to each other. I will have 5x minus 5 equals 3x plus 8. Now I can solve this equation. However, this one's a little bit different because before we can solve for x, we want to isolate x and get it by itself. Now I have 5x minus 5 on one side of the equal sign, and I have 3x plus 8 on the other side of the equal sign. So what I want to do is get the x's together on the same side of the equal sign, and then I can solve for the equation. Now, in order to get them on the same side, I have to use inverse operations to move them. Because there's an equal sign in the middle, the only way I can move something to another side of an equal sign is by using inverse operation, by undoing something. So if I want my x's together, I can do one of two things. I can move my 5x to the right side, or I can move my 3x to the left side. My personal opinion, I always like to move the smaller x, so that way I stay positive. If I move my 5x to the right, I'm going to end up with negatives, and I rather deal with positive numbers. So I'm going to take my 3x and move it to the left side. I can only move it on the other side by using inverse operations. Since this is a positive 3x, I'm going to subtract 3x, and what I do to one side, I have to do to the other side. That is so important in equations. Those are going to cancel out, and now I have 5x minus 3x. I can combine like terms. Now that they're on the same side of the equal sign, I can combine like terms. 5x minus 3x will give me 2x. I still have a minus 5, and now on the right side, I'm only left with a positive 8. Everything else is gone. Now I can solve this by undoing what is being done to x. Being multiplied by 2 and subtracted by 5, the shoes and socks principle tells me I have to undo the subtraction and then undo the multiplication. So to undo subtraction, I have to add. I add 5 to one side, I have to add it to the other side. So now I'm left with, and I'm going to come over here, 2x on the left side, and on the right side I have 8 plus 5, which I can combine to make 13. So now I just need to get rid of this multiplying by 2, so I'm going to use the opposite of multiplying, which is dividing, and what I do to one side, I have to do to the other side. Now I'm left with x by itself, which is what I want. That's my goal when I'm solving equations. And 13 divided by 2 is 6.5. That means that 6.5 is the value that when I plug it into these equations, these two angles would be equal or congruent. Let's figure out what the angle would be. So I'm going to plug it in. Let's do it on angle A first. That means angle A is going to be equal to 5 times 6.5 minus 5. When I simplify this by using the order of operations, 5 times 6.5 is going to be 32.5. And then I'm going to subtract 5. 32.5 minus 5 is 27.5. And since we're dealing with angles, we want to put degrees. So angle A is 27.5 degrees. Now, if this is the correct solution, when I plug it into this angle, since these are congruent, I should get 27.5. So let's check if that works. Angle D is going to be 3 times 6.5 plus 8. 3 times 6.5 is 19.5 plus 8, and 19.5 plus 8 is 27.5. And again, we're dealing with angles, so we're going to put it in degrees. Now I can see that both of these angles are equal, which is true because these are similar figures.